Hello, geometry, and welcome to lesson 6.3 on properties of parallelograms. This is huge, right? For some reason, State of Ohio, Common Core, they love parallelograms in geometry. And I think it's just because of all the relationships within a parallelogram. Now let's discuss what a parallelogram is. I think you should know, right? But a parallelogram is basically a rectangle slanted on its sides, right? The big thing about a parallelogram is that the opposite sides, both pairs, are parallel. So these two are parallel, and the top and bottom are parallel, right? So opposite sides are parallel. That's what makes it a parallelogram. Okay. So in this lesson, we're going to explore the many other properties of parallelograms, do some proofs, and have some fun. All right. So explore opposite sides. How do the lengths of the opposite sides of a parallelogram compare? All right. Well, what we're going to do here is we're going to do a proof, right? So we are given that this is a quadrilateral. So we're given. Now the shorthand for, we're given that this quadrilateral is a parallelogram. The shorthand for parallelogram is a little symbol of a parallelogram and then the naming, ABCD. All right. So we're given parallelogram ABCD. We want to compare the opposite sides. All right. So step one of this proof is the given. So step one, parallelogram ABCD, and again, that's given to us. Okay. So step two, what we're going to do here is we're going to draw in BD. BD is one diagonal. Okay, so we're going to draw BD, and again, we're just going to do that, like you could say construction, whatever, but really no reason. We're going to draw BD. So what we've done is we've created two triangles. Now, AB and CD would be a pair of opposite sides. AD and CB would be a pair of opposite sides. We want to prove that they're congruent. Well, if we can prove these two triangles are congruent, then by CP/CTC, those opposite side pairs will be congruent. So let's see if we can do that. Okay, so step three, and again, this is like an informal proof, right? So segment AB is parallel to segment CD, right? We know that because that's the definition of a parallelogram. So if AB and CD are parallel, what I'm going to do here is introduce some angle numbers. 1, 2, 3, and 4. This makes it easier for me to do. So if AB and CD are parallel, let's do AB, CD, and the dotted transversal. Hopefully you can see that angle 1 and angle 4 are congruent. Angle 1 is congruent to angle 4. And again, they're alternate interior angles. Now we can do the same thing with the other pair of parallel lines, right? AD and CB. We know that AD is parallel to CB because it's a parallelogram. So again, if I trace those in green and trace the transversal, now hopefully you can see that 2 and 3 are also alternate interior angles. They're congruent. Angle 2 is congruent to angle 3 by alternate interior angles theorem. So that, my friends, is two angles, an angle pair and an angle pair. Now, if you recall from our topic 4, right, when you're trying to prove two triangles congruent and they touch like this, we can always use that middle side shared as a segment congruent to itself. So BD is congruent to BD. That's that reflexive property, yes, because it's used in both triangles. And that is the side we need. And these two triangles are congruent by angle, side, angle. So triangle ABD is congruent to triangle CDB by angle, side, angle. And because of that, the opposite sides, which are corresponding parts, are congruent. So AB is congruent to CD, and AD is congruent to CB. And that's by CP/CTC. So how do the lengths of opposite sides compare? We just proved that the opposite sides of a parallelogram are congruent. That's an E, sorry. That's terrible. Are congruent. So as I mentioned, right, a parallelogram is just a rectangle slanted. Opposite sides of a rectangle are congruent, so it would make sense that the opposite sides of a parallelogram are also congruent. So the opposite sides are parallel, and the opposite sides are congruent. So here is the formal theorem. So if a quadrilateral is parallelogram, then its opposite sides are congruent, right? So we know that WX is parallel to ZY, and WZ is parallel to XY, so then those opposite sides are also congruent. Okay, so if you look here in the picture, 5.8 equals 5.8, 7.1 equals 7.1. Let me go to Savvis and we'll do a little bit of a exploration. So if I click and drag, right, so they're staying parallel, right? Notice they're parallel and they stay the same. 12.3, 3.1, 9.5, there you go. Okay. So believe it. Okay, all right, so let's do some algebra possibly. Here we go. So quadrilateral PQRS is a parallelogram. What is the value of x? So if you look here, right, x is in the side lengths. We should know that the opposite sides are congruent. So we should know that 4x QP is equal to 5x minus 3 RS. We should know that 7x minus 3 is equal to 2x plus 12. So there's really two ways to go about this, and I'll show you both ways just for fun. You could do 4x equals 5x minus 3, or you could do 7x minus 3 equals 2x plus 12. Either way, you'll get the same x value. Now, I believe that this first one is going to be less steps, so let's do that first. So I'm going to bring the 5x to the left by subtracting it. 4 minus 5 is negative 1x equals negative 3, and then divide by negative 3. And you get an x value of positive 3. I think the same thing will happen here. There are no like terms to combine right now, so let's move across the equal sign. I'll subtract 2x from both sides. That's going to make this a 5x minus 3 equals 12. I'm going to add 3 to both sides. That makes this a 5x equals 15, and divide by 5. And x is also 3. So no matter how you slice it, boom, you get 3. And now part B says, what is the length of each side? So we need to find the 3 lengths of PQRS. So to find PQ, I'm going to plug in 4 times 3. That's 12. That's also going to be the same as RS. If you want to test it out, 5 times 3 is 15, minus 3 is 12. Same thing with QR. We're going to plug it in. 7 times 3 minus 12. That's 21 minus 12, which is 9, which is also the same thing as SP or PS. Oh, I'm so sorry. I apologize. I mixed up. 7x minus 3. So excuse me for a second. So this should say 7x minus 3. So 7 times 3 minus 3. It's this right here. So I just wrote down 9 instead of 3. I don't know why, or 12, whatever. So this is 21 minus 3, which is 18, which is also PS. And again, if you do 2 times 3, that's 6, plus 12, that's going to be 18. Opposite sides are congruent. All right, I'm going to stop the video there. We're going to move on to angles next, all right, with video 2. Keep watching.